Everybody, and welcome back to the CIB Presidential Seminar Series that we're broadcasting from Purdue University. And as you know, the theme for this semester has been distinguished women researchers in the built environment. And in continuing in that series, we have yet another distinguished speaker today with us, and that's Dr. Isabel Chen. She is Assistant Professor and Program Director of BSc Department of Real Estate and Construction at the University of Hong Kong. Dr. Chen is Assistant Professor and Program Director of Surveying in the Department of Real Estate, as I mentioned. She is also the Chairman of the Institute of Safety and Health Practitioners, Co-Chairman of the Associated Research Centers for the Urban Underground Space Youth Group, Joint Coordinator of W112, which is Culture in Construction. That's the CIB Commission. Panel member of the Appeal Tribunal Panel of the Planning and Lands Branch Development Bureau, HKSAR. Member of the Youth Affairs Committee, Construction Industry Council of Hong Kong. Member of STEAM Alliance, STEAM Alliance, Hong Kong Institute of Construction, and executive committee member of the Hong Kong Federation of Occupational Safety and Health Association. In addition to various Best Paper awards, Dr. Chan was awarded the Doris-Zimmern Hughes Hall Fellowship from University of Cambridge. Her research interests include underground space and health, construction, health and safety, stress management, leadership, culture, sustainability, and so on. In line with these, she was successfully awarded various external and internal grants. The fruitful project results were widely disseminated through books, international journals, conferences, workshops, and seminars. Please welcome Professor Chan. Isabel,
Thank
over to you.
Thank you. So first of all, I'd like to thank Purdue University and CIB for the invitation. I'm really, happy to be here to share with you like the latest findings of my research about underground space, wayfinding, and human health. And in this guest lecture, I'm going to share two pilot studies, in which the first one would be about the integrative analysis of how underground environment would affect human health. And in that study, it covers both the survey and field measurement methods. And the second part of this section would be the VR experiment, which aims to investigate the impacts of signage, especially the colors of signage and noise together on the underground space occupants' health and their cognitive function. So underground space, whenever we talk about underground space, people may easily associate it with tombs, bunkers, or even like sewage system, something that was not that pleasant. And if we talk about like staying underground, oops, are you kidding me? That's really what's happening in some cities when the government share, their underground development plans, and when it was still at the beginning and people were not that clear about, whether the government was talking about having underground commercial space or transportation space or really residential space. So people, were really hesitating. But indeed, human being, we do have a long history of using the underground space, of staying underground. I believe some of you may have heard of this place in Turkey, Cappadocia. So this is actually much more than underground caves or underground cities. It has a very long history, and you can see from the figure on the left-hand side that it's very systematic. There were 7 underground levels, and you can see that there is a church at the bottom. There are schools, there are like retail areas, and so on and so forth. So this is actually a very well-planned underground space. So the archaeologists found that the people, they built this area for the Christian to hide from the persecution from the Roman Empire in the old days. So you can imagine, this place has housed thousands of residents in the past. And similarly, in Hong Kong, if we do have, I'm not sure whether we have participants from China or not. So if you're from China, then you may have heard of Yaodong. which is very common in Shanxi, which is a province in China. So Yaodong has a very, very long history that goes back to centuries. And according to the latest findings, statistics conducted in 2006, at that time, there was still like over 40 million people in the northern China who was living in Yaodong. So you can see that people living in this type of underground space, they are protected by, effective insulator. So these insulator can keep the underground space like warm in the cold season and also cool in hot season. So a lot of benefits indeed. So nowadays, urban space is becoming more and more common. So we can easily find underground shopping malls, subway stations, together with the pedestrian network systems, underground offices, and also car parks around us. If we look at different cities, we are actually facing rapid growing of populations, right? So, however, in many of these areas, we have limited urban expansion above ground, and that's why there are more and more underground developments needed, and there are more and more underground space which are to accommodate occupants. You can see this phenomenon can easily be found from countries around the world, like Helsinki. Comparing with the increase in population density, its increase in urban underground development is actually much more significant. Similar trends can also be found in Beijing, China. And we can also see that more and more countries are going to adopt a plan of digging deep, like China, Canada, the USA, Finland, Sweden, and so on and so forth. Of course, they use it for different purposes. And I got this figure from the Singapore's Urban Redevelopment Authority, which shows some common uses of underground space, like for pedestrian network, railway, roads, etc. And these are actually getting more and more popular. For instance, you can find that in terms of the underground pedestrian network, Montreal has the highest density around the world. And then second to Tokyo and then Helsinki, and in Singapore, in terms of underground road density, Hong Kong is also taking the lead, and so on and so forth. So we can see that, there are many more and more underground developments around the world. However, still, underground space is facing, many criticism, and in general, the public has a rather low acceptance towards staying underground. It's quite easy to find these types of news around the world, like people are concerned about the air pollution, the noise problems in underground space. There are also many similar news in China as well, but because it's in Chinese, I've chosen, the English ones here. And in addition to like noise and air pollutions, we can also find, some obvious differences between underground space and also above ground space. For instance, the lack of natural lighting in underground space and the lack of physical connectivity with the outdoor environment, and also the lack of visual connectivity with outdoor environment, because it's like unlike above ground building, we will have window views, which can connect us with the natural environments. There can be trees, there can be landmarks, which can also, in addition to like enhancing our psychological health and also physical health, these landmarks can also help us in orientating ourselves within the building environments, which can also enhance our efficiency in wayfinding. But without these, wayfinding in the underground environment is actually challenging. So in fact, underground space users, they have special needs because of these limitations that can be found from the underground space. However, currently, there is no guidelines distinguishing underground space from the above ground space design. So it can, most current underground developments these days are designed without human considerations. They actually ignore the underground users' needs on like connectivity with the above ground environments, their visual connection to the nature, their wayfinding needs, the lighting needs, acoustic comforts, and so on and so forth. So these are actually pictures taken from some underground space in Hong Kong. They are crowded and lack of acoustic comforts and visual comforts. Some of them are in lack of signage, which can guide them to, wayfinding and so on and so forth. So this is, what is happening in underground space these days. And there have been some literature which shows that, these characteristics of underground space can have significant impact to people's health. For instance, the lack of exposure to natural lighting can affect people, underground occupants' circadian rhythm, which can also, in addition to affecting their sleeping quality, these can also cause all other types of physical health risks to the building occupants. And for example, the air pollutions can also affect cause different physical problems to the occupants, and also the segregation between the above ground, also the external environments can cause the social health risk to the individuals. And as mentioned, there can also be challenging in wayfinding, which can in turn also cause the physical and psychosocial health risks to the underground occupants. So because of all these, we started to conduct a study on underground environment and human health. So the ultimate goal is actually to develop a quantitative facilities management and health model for underground space users. And so these are the objectives. First of all, we try to identify the facilities management components in the underground space, and then we identify the health indicators of the underground users, and then we try to investigate the associations. So here we have taken the perspective of facilities management. So what is facilities management? According to the IFMA, FM is actually a multidisciplinary concept. It aims to coordinate the physical environments, the assets. So in this case, it would be the underground shopping malls, pedestrian subway systems, offices, recreational facilities, and with people, the occupants in these underground space. For the organizations, it could be the subway station companies, it could be the retail companies, commercial companies, with a goal to serve the strategic objectives like ensuring and enhancing health of the users. And from the extensive literature review, the holistic FM in underground could cover 3 aspects: space management, building services, which are mainly referring to the indoor environment quality, and also supporting facilities. And in terms of health, actually health is not just about the absence of disease, physical disease, or being happy. According to the WHO, it's actually a broad range concept, which mainly covers physical health, psychological health, and social health. So in this study, we try to identify the associations between different types of space management factors, building services factors, supporting facilities factors in these underground space on users' physical, psychological, and social health. So we have also conducted a systematic literature review. We started to perform the SLR on Scopus. So we first of all targeted peer-reviewed papers published in the past 2 decades. We used the keywords like underground, thermal, temperature, humidity, IAQs, and all sorts of environmental quality related keywords. And this resulted in around slightly higher than 3,600 empirical studies. And then we refine it to those which are directly related to human health, both physical and psychosocial health, and also those which have empirical quantitative support. So there have been studies which were theoretical studies. There were also studies which adopted a qualitative approach like interviews. But in this SLR, we focused on the quantitative ones. And this systematic literature search resulted in 17 studies. So as you can see, more than half of these studies, they were done based on single underground projects. And furthermore, nearly 95 of these studies, they focus on single underground developments only. In terms of the type. And then amongst the 7 studies identified, nearly 90% of them, they adopted a single method, like questionnaire survey only, most of them. And then only 2 adopted a multi-method approach. And that is a combination of questionnaire survey and also a field measurements for these two studies. However, these two multi-method studies, they both focus on the physical health of participants only. They didn't really focus on, both the physical and psychological health. And based on this gap, we further continued with our studies. So this map shows the 12 underground sites that we have identified in Hong Kong. So I'm sure many of you may have been visited to Hong Kong. So in Hong Kong, there are few districts. So the upper part is actually the Kowloon area. The lower part is the Hong Kong Island area. So in Hong Kong Island area, it has much higher density, urban density, and in the upper areas, the density is lower. So we try to have a good mix of underground sites with different neighborhood environment. So these are the 12 sites. There were subway stations, there were shopping malls, there were also some office buildings. So this table summarizes some characteristics of these sites. We try to have a good mix of different building age and different types of underground sites usage. They are from different locations in Hong Kong and different underground design, and they also have different types of wayfinding. Some of them didn't really have a wayfinding system, but some of them would have the wayfinding, the signage system together with the zoning system, and they have different areas as well. So in addition to these 12 underground sites, we further identified 12 corresponding above ground sites in which they have comparable locations and features with those 12 underground sites. And in total, we have collected 348 responses from the underground sites and 303 responses from those 12 above ground sites. So then we have conducted an independent sample t-test analysis to compare the health, both physical and psychosocial health of the occupants in the above ground sites and also in the underground sites. And then we found obvious significant differences in terms of the participants' physical health indicators, including the building-related symptoms and also the insomnia, like the sleeping quality. And also in terms of psychological health, it covers emotional exhaustion, burnout, claustrophobia. So these are the psychological ones. Interestingly, there is no significant difference in terms of the social health issues, like the personalization of these two groups of building occupants. So in general, the above ground occupants, they have, a significantly better health, both physical and psychosocial health. And then in order to further investigate how their health was being affected by different facilities management factors in the underground space, we have conducted regression analysis to see how these groups of the variables predict different types of health indicators. So the findings is summarized in this figure. So as we can see, in fact, all of the identified underground environment factors, except the visual comfort, they have significant impacts to both or either of the physical and psychosocial health. So in order to further validate these results, we have further conducted a field measurement studies. So in this field measurement studies, we have adopted an objective measurements approach. We measure the temperature relative to the humidity, air velocity, air quality, and so on and so forth in these underground sites using these equipment and throughout the 9 hours in a day continuously, and then we take an average of that. And for the greenery, we actually measured both the quantity plus the quality of the greenery. We adopted a readily available measurement scale and to measure how the research assistant who are going to who collected the data from the site on their green perception in terms of the variation of the greeneries there, the maintenance quality, the arrangements of the greenery, and so on and so forth. And also in terms of the connectivity between above ground and underground space, we also counted the number of staircases, the lifts there, escalators, and then we have some calculations on the density of these. And in terms of wayfinding, we have also recorded different characteristics of the signage design in these underground sites. So these are the 6 underground sites that we have covered in this field measurement studies. And again, it has a mix of different usage and different building age. And from S1 to S6, they represent a descending order of the occupants' physical and psychosocial health. It means that in S1, the occupants have the best level of physical and psychosocial health. And for S6, their health level is the poorest. So, so on the left, from left to the right, it represents a decrease of occupants' health. So from this trend line figure, we can see that the higher the temperature, then the poorer the occupants' health. So one of the sites at 6 on the right-hand side, it is found to be outside the excellent class range. As you can see, there is a green dot there. And it also has the poorest occupant health measured. And then in terms of relative humidity, amongst the 6 sites, there is one which is again outside the excellent class range. And the trend line also shows that the higher the RH, the poorer the occupant's health. And then for CO2, the concentration of CO2 in the underground space. So as predicted, the poorer the occupant's health if the concentration is higher. So, but it's actually surprising to find that amongst the 6 sites, 2 actually fall out of the range of the good, even the good class. So it means that, you know, air quality is something that we really need to pay attention to in underground space. And then another indicators for air quality, HCHO, again, the higher its concentration, the poorer the occupant's health. And here all sites fall within the range for the good class. And then in terms of greenery, the higher the green perception, the better the health, as predicted. And then in terms of the noise level, so there are different standards for different usages. So as you can see, in general, amongst the 6 sites, 5 actually falls into the range with no credit under the Hong Kong GBC guideline. So as predicted, the higher the noise level, the poorer the health. And then for space design, again, the higher the satisfaction towards the wayfinding effectiveness, the better the health. So somehow, so overall, the field measurement studies, they confirm the survey studies on which, you know, these how these underground environment factors will affect the physical and psychosocial health of the occupants. And amongst all these space factors, we can see that space design, which also covers wayfinding, is found to be one of the most influential factors which significantly predict human health in underground environment. So next, we're going to talk about wayfinding in underground space. So as we all know, unlike above ground environment, which has certain connectivity, mostly at least the visual connectivity with the outdoor environment or natural lighting, which can act as reference points for one to orientate themselves within a building. Wayfinding in underground space can be very challenging. So according to the literature, building occupants' wayfinding performance can be affected by 4 factors. And for instance, individual difference. So individual difference, I mean, individuals may have different knowledge or familiarity with this space. So, you know, that will cause difference in their wayfinding performance. And secondly, architectural setting, such as the natural lighting, it can help them to better find, you know, orientate themselves and find the exit, or the corridor design, the width of the corridor, and also whether the turning point is smooth or not, which will affect their visual capacity. These will also affect people's wayfinding ability. And the third factor would be training, like videos or, you know, VR-based training. Through trainings, people's wayfinding skills can be enhanced. And also, fourthly, it would be the signage and utilities design. So, for instance, in terms of signage design, there could be a difference between using the arrow for the signage and using an icon. And the other design considerations could be the location. Where are we going to place these signage? Are we going to place them on the ceiling or on the floor? So that could also be a difference. But in this study, we're going to focus on colors. Why? There have been some previous studies which, in fact, most of the existing wayfinding studies, they focus on evacuation. So similarly, in this study, they found that they tried to investigate the impact of color of the safety signage on occupants' escape performance and also their physiological states. And the finding is that amongst all these 4 types of the signage, the A type, which has the green and black color, they can achieve the best evacuation performance, the lowest level of cognitive load, and then the high search efficiency. So the explanation in this study was that different colors may have different meaning to people. They have conducted a survey before this virtual experiment, and they found that the participants, they tend to associate red color with the message of stop. Yellow may mean warning, and blue and white could mean indication, information. And for green, it's often being associated with goal and safety. And, that's, how different people would interpret these colors differently, because in this study, they focused on Chinese participants. And there could be a possibility that, different people may have also, some different types of interpretation. So the other aspects is underground noise and human health. And due to the enclosed nature in underground space, the impact of noise has long been another important area of research focus in the field of underground occupants' health. So the majority of the underground noise studies, they focus on the mining sites. For instance, there has been some studies focusing on how high noise in those mining sites escalates the heart rate of the workers there. And there have also been some studies finding out the effects of noise on health of individuals could be different depending on their sensitivity, and so on and so forth. So there have also been other studies focusing on the above ground environments. They found that noise can actually affect our stress hormones by stimulating our hypothalamus and also stimulating our prefrontal cortex. And all these would actually manifest as our stress behaviors, our response behaviors. And also, if there are different background source of noise and different intensity, our satisfactions would also be different. So in the literature, there has been studies which indicated the effects of noise and wayfinding system on underground occupants respectively. But there is a lack of investigation on their combined effects. So in fact, there have been some previous studies, though they are not really focusing on signage or focusing on noise or not really on the underground environment field, but they have kind of hinted that the effects of the visual and also the acoustic stimulation of occupants would be affected by that of each other. That could be distraction when both of these stimulus appear at the same time. However, the degree to the effects in underground space is actually unknown, let alone the specific areas in this study, like signage colors and also the noise for wayfinding. So in this second part of this seminar, I'm going to go through the other study, which is actually a VR experiment for the effects of signage colors on wayfinding and psychophysiological health of occupants in underground space with different noise levels. So this is the conceptual model. I want to combine visual stimulus and also audio stimulus, combine the effects and see how they would affect the psychophysiological states in terms of the mental fatigue, mental workload, alertness, and anxiety levels of the underground occupants during their wayfinding process. And at the same time, I will also measure their wayfinding performance. That would be, by measuring their time needed for completing the wayfinding task. So we have adopted a VR approach. So first of all, we developed the VR model together with the interactions in the model using the 3ds Max and also the Unity. And then for the hardware, we use the HTC Vive Pro 2 for the players to visualize and interact with the underground environment. So we have utilized an underground site, the underground model, and there are two types of signage system that we have embedded. The first one is the color-coded signage. So in addition to the signage, those exits were also zoned. So in total, there are 4 exits, 4 zones in this model. And they are all colored with, they all have different colors. And in the other groups, it's just a black and white signage system. There is no additional color. And in terms of noise level, in this study, I have only incorporated medium noise and low noise level in order to minimize the potential risk of hearing loss to the participants. So it's just the low and medium noise. And the source of noise were the speaking noise of the occupants, the walking noise, and also the mechanical noise, and also the noise that we can commonly found from the background noise of within the underground station. And so this would, comprise a 2x2 matrix resulting in 4 groups. Like the first group would be black and white signage together with low noise scenario, and then black and white with medium noise, and then color code signage with low noise, and then color coded signage with medium noise. So these 4 groups of design, and there were 43 participants in this study. And so we tried to evenly distribute these participants into the 4 groups. At the end, we found that there was 1 participant from the CLL group in which because of the connectivity, there is some noise from the data. So we have to remove that, resulting in 10 participants in this group. But in all other groups, there were 11. And in terms of the gender, we have a good mix of female and male, and most of our participants are at a young age, 18 to 29, and they are all, they're all healthy with the BMI under 24.9. So the experimental procedures. Before the experiment, actually we reminded them all the health control, such as no coffee taking, no alcohol, no vigorous exercise, and so 24 hours before the experiment. And then upon they arrived the lab, we collected their demographic background, and we asked them to fill in a health survey to record their health status plus the behaviors. And also, and then before we start the experiment, we actually let them play a mini VR game so that they're equipped with the necessary skills for controlling the controllers to move around the model. And also, very importantly, we also want to ensure that they have no motion sickness, no VR sickness. And then we also adjust their VR headsets and EEG to make sure that the connectivity is in good quality. And then that would be the start of the wayfinding experiment. So we assign them into one of the 4 scenarios, and then we time their wayfinding task. And after the experiment, they would be asked to conduct a VR sickness survey again. So this is the timeline of the wayfinding experiment. So the beginning of this VR game, this VR game started on the subway. So where they would got the instruction about what they have to do, they have to, join, they have to go to, an office within certain periods of time for job interviews. That's why time is pressing, trying to create some stress for the players. And then, this is how, and then they would click the start button, and then, they would try to find their ways in the platform, and they can be, they can have a look on the signage and also the map there. And, finally, they can find the correct exits and then go to the office. And here, the wayfinding performance was measured by the time from when they click the start button to the time that they reach exit B. That's how we counted T1 to T2. And then that's the wayfinding performance. And then for the psychophysiological states, we used EEG to measure, how they react or respond in terms of their brain activities. So previous neuroscience studies, they have already proven the effectiveness of using brain waves detection to indicate different human psychophysiological states, like alertness, mental workload, mental fatigue, and anxiety. So in addition to simply using the gamma, beta, alpha, theta, delta brain waves, because it can have many different implications at the same time. We have used these well-validated equations to measure these psychophysiological states instead. And then the finding is that, interestingly, for wayfinding performance of participants using a color-coded wayfinding system, it's actually poorer, regardless of the noise level. Okay, so we'll probably there is actually some support that we can find from the literature, because the black and white scene is actually a representation of the cool color tones, right? For the other color ones, it's actually the warm color tones. So there have been some studies finding that the cool color tones are actually associated with better task results and better memory for human beings, because the cool colors can increase people's concentration at task. And there are also empirical evidence finding showing that we may always think that the warm colors like red can enhance our performance or our attention, but that would happen to simple tasks only. But for wayfinding tasks, it's rather complicated. The cool colors can improve performance on these difficult tasks. So this study actually, echoes with those previous studies. But, it's quite surprising and interesting. And then in terms of the psychophysiological states, in fact, we can see that in terms of alertness, mental workload, and mental fatigue, the levels are actually higher in the color-coded wayfinding system team. So what does it mean? Again, so environments with warm colors such as red, orange, they tend to provoke higher brain activation and arousal. So this can explain why we can have the higher levels of alertness, of mental workload, and mental fatigue in all these groups. And if we look at anxieties, it was indicated by the difference between the equation actually means it was calculated based on the difference between our left and right frontal alpha activities. So the negative values here indicates that the frontal right alpha activities is actually higher than the frontal left alpha activities. And this will happen when individuals are exposed to a stressful stimulation. So it actually means that for the color group, they have the higher in negative values. It means that they are experiencing higher levels of stress. So, and then in noisier environments, we can also see that both of the black and white and also the color groups, they require longer time to complete the wayfinding task, as you can see from this, because the two lines are both going up. And probably it's because of the higher distraction created by the noise that requires longer time for both groups to complete the task. And then for the black and white groups, we can see that the higher level of mental workload and fatigue are found. There can be an implication of higher level of attention required for wayfinding that would result in higher level of mental workload and fatigue. If you still remember, in those two figures, the lines are going up if the noise levels increase. But interestingly, for the color groups, when we have increased noise level, the alertness, the mental workload, and fatigue are actually found to be lower. So this can be a potential indication of overstimulation, because at the same time they have to receive the multi-color information together with the noise. So the information overloading can cause overstimulation, resulting in lower levels of these brainwaves activities. So though the study found empirical supports that underground occupants' wayfinding performance and their physiological states are better in black and white signage systems, and that the color system may overstimulate occupants in their wayfinding process, we still think that it may be too early for us to draw up practical recommendations at this stage. And that's why we believe that further studies are required to further investigate. First of all, would there be a difference in terms of color mix and also the color tones, which may have indication to, or which can help us to prevent the overstimulation that we have found in this study. And also in this study, we have not included the high noise level. But in some previous studies, some of the underground sites have found to have a noise level as high as 70-something. So perhaps instead of, but 70-something could already cause some hearing damages to participants. So instead of creating unnecessary risk to the participants, future studies can be conducted on the field to see how, in reality, people's psychophysiological states would be affected by those high noise level. And also in this study, we have just covered the background sound, which are commonly found in the subway station. But there may be a difference in terms of the impacts if the sound source is different. Let's say if it's music or if it's the information, or if it's the nature's sound. So future studies, it would be interesting to further dig deep into these areas. So that's the end of my sharing. I hope you enjoy that.
Dr. Chen, that was very interesting seminar indeed. Let me open the floor for questions. Anybody wants to go first? I have a few questions, but I want to give, see if the audience has a question. If you have a question, please open your mic and ask, or raise your hand so I know that you have a question to ask. But while you're thinking, let me ask a question. So, some of your results were very, very interesting, particularly with respect to noise and color combinations in an underground environment. But recently, in one of my interactions with some architects, I was asked a question that in the present generation, we see kids and young people looking more at the screen and getting their stimulation from the screen and finding reality in that environment as opposed to nature.
Mm-hmm.
And so the question was, would windows even be necessary? And I found that quite interesting. And now looking at your research, so my question is, what can you draw from your work that might shed some light on that question?
Thank you, Mark. So in fact, in this study, we have used the VR method, right? So again, it's digitalized, it's not real. But there have been some previous studies which have compared the effectiveness of the virtual visual impact with the real impact, and they found that it's comparable. So probably that can answer your question to some degree, but I haven't tested it in this study, but in underground space, because the visual connectivity with the natural environment is really restricted. So probably there have been, in some of my previous studies, I have made recommendations like having some virtual windows, which can show the participants what it looks like in the above ground. It could be trees, it could be oceans or city views, something with motion as well. But of course, there could be different options for underground space with different usages. Yes, but your question makes me, I have to further think about there may be a potential impact. Though in previous studies, there are some correlation being confirmed.
Yeah, indeed. Uh, anybody else wants to raise a question? Open your mic and ask a question.
Hello, this is Philip Dunstan.
Go ahead, Philip.
Thank you so. Yes, thank you. Thank you so much for the presentation. I found it very fascinating as well. I just want to try to clarify my understanding of one point, or maybe a couple of others. You were only manipulating the color of the wayfinding signage. Is that correct?
Together with it's actually the wayfinding system. So wayfinding signage, yes, is black and white and also colored, but in the exit, the frame of the exit is also colored.
Okay, all right. So that speaks to what I was wondering about, was the effect of the general environment, the mix of colors, if you will. So,
yes.
What are the walls and the floors? What are their colors versus the colors of the wayfinding system? And if that contrast or blending of colors, mix of colors, might have an influence. Is that something you could comment on?
Well, in the previous studies, there have been many literature. In fact, in this study, it's a mix of both the signage plus the environmental colors. But in the previous studies, there have been a lot of studies investigating the impact of the environmental colors, like the color of the entire classroom, the colors of the entire hospital dome, and so on and so forth. And if we have to mimic the real environment, let's say for the subway stations in Hong Kong, actually the common approach is having a mix of signage plus the background environment in terms of something like zoning. So to better help people to, find their ways. I'm not sure whether I have answered your question or not.
Well, I mean, and I don't know if there is an answer that you could know the answer, so I'm not sure. I was just wondering what anyone has studied, yourself or others you've seen in the literature, about the broad environment, the color scheme of the broad environment.
There have been a lot of studies on the color scheme of the entire environment.
Okay, but in your study, the focus of attention is around the elements of the wayfinding system.
Yes.
Okay, correct.
Because the dependence is about their wayfinding performance plus their physiological response during the wayfinding process.
Okay.
Thank you for your question.
Yeah, that's good. Another question. Again, I'm thinking a little bit beyond your study here, but can you comment on what is known about the type of lighting, the nature of the lighting? Because it's all artificial, but there can still be different types of artificial lighting. Is that something you have noted or considered?
You mean type of lighting, like natural lighting versus mechanical lighting?
No, well, we're underground space, so let's assume it's all artificial light. So it can have light that's more in the yellow end of the yellow band of the spectrum versus whiter light and all of that.
Yes, there is study about the light intensity and the light spectrum for the underground space already.
Okay, and as far as the effect on health, is one noted to be better than the other?
Sorry, I've missed your question.
As far as the effect on human health is concerned, in underground spaces, has one been determined better than the other? Such that what is there a general practice, a recommended practice regarding that? I guess that's a better way to frame the question.
You mean how can we enhance the underground space for human health?
By the choice of lighting, About the choice of lighting, the
okay.
design of lighting.
So that's not from this study, but I remember I've come across the studies about the different colors of light.
Mhm.
The orange and yellow type of lighting, because it's closer to the sunlight, they were found to be better for human health. But I would suggest you to go to the literature to dig it up. It's just based on my memory. But there has been there is also other studies which found that even though the artificial lighting can be tuned in terms of the color, it can be tuned to be similar to the sunlight, but it cannot replace sunlight. And that's why in some of the underground space, we try to have more sunlight by having like what's that called, the glass ceiling, the big atrium, light well, and so on and so forth. There are more and more of this type of design.
Okay.
I hope.
Okay. Okay. So there's a
Mhm.
desire to try to get as close to the natural reproduction of natural light as possible.
Exactly.
I might
Thank
think of another question, but I'll let someone else have the floor.
No, thanks. Those were really interesting questions. So that was Professor Dunstan. Anybody else? Question? Well, so let me pick up on what Philip was pointing out. About Ali. Hold on, I'll get back to you just in a second. That I saw your results based on just black and white versus color and the fatigue levels that you observed in your study. I thought that was very interesting that black and white should lead to more fatigue than color, if I capture that right. Would you be able to shed some light on that? Why?
That's what I expected at the beginning. That's why I also found this result very surprising. And I would think that there is a difference between how like the perceived level of psychological health and the real like objective physiological response that we measured using EEG. Because here we are more focusing on how we process different stimulus within an environment. And I have actually spent quite a lot of time in digging into the literature again in order to understand the findings. And I found that in the neuroscience research, in fact, if people are facing multiple stimulus, especially in terms of visual and audio, then we will be information overloaded. And that would cause overstimulation. And that would actually reduce our ability to put attention in the task that we are working on. And that will also increase our stress level. So, that's why I found this quite interesting.
So is there a work that are you looking at extending your work to show that between the noise level or the decibels and when correlated to the color palette, that what combination is suitable for what environment? So if you are, you want to have less stress, less fatigue, what combination of lighting and sound would actually you will be able to achieve that, and vice versa, of course, right?
Yes, thank you very much. Definitely. It will be very interesting to see, because in these studies, it's just black and white. And then for the color coded system, there were just 4 colors. And if we look into the color tone studies, there are, it's actually really a spectrum of
Right.
color. So it's, we are going to put more resources into looking into how these different colors and their integrated effects with the noise will affect people's psychophysiological states.
Okay, great. Yeah, thank you. Ali, you had a question?
Hi.
Go ahead.
Yes, this is Ali. Thank you for the great presentation. I really enjoyed it. And I might have missed, part of your discussions, but your results were for normal situations, right? Normal populations under normal situation. But in case of a disaster, when people have to evacuate from underground area, and then I was wondering in that situation, maybe switching to color would be, a better approach so that people can pay attention and the choice of color, I think, is important, because naturally we kind of associate red with stop and then green with going road. So that's why the exit signs are usually in green. So I was wondering if you've considered, maybe under normal situation, we have a way of, optimum choice of lighting and environment design, but under disaster situation, we kind of switch to that mode so that we can facilitate the evacuation under an emergency case.
Yes, I agree. Because for this, because in the literature, in the underground literature, in the wayfinding literature, actually the majority of it is about evacuation. So that part is actually well studied. And that's also why in our study, we are not focusing on the safety signage. We are focusing on the normal signage, which help people to, find their ways in normal situations. And that's how we position our study for the gap. But I agree that that would be a difference between, because the purposes of these different types of signages are different.
Yes, that makes sense. Thank you.
Thank
Thanks,
you.
Ellie. Anybody else? Questions?
I have another question.
Yes, go
First
ahead, please.
First, a comment. I liked Ali's question, the direction it was going in, because, and as you two were talking earlier too, because you probably want to try to find this balance between alertness without overload or overstimulation, right? So that
Yes.
to me, that sounds interesting in the form of a challenge. Going back to your earlier assessment of health, the populations that you were, I guess you were surveying, they were self-reporting their health conditions. One thing I think I missed was, in order to be a part of that sample, what duration of time in this, was there a minimum duration of time in the underground space that framed your study there?
Yeah, this is a very good question. We do have at least 1 year.
At least 1 year
Yes.
of time there. Okay, all right.
Yes.
And that would be, and what would qualify for that? How many hours per day or per week, or
Okay,
qualified?
for this one, we do not limit the number of hours, but we measure that, we ask that question, but we do not screen out those respondents. And in fact, the targets are all the people who work in those areas. So for let's say for shopping malls, it's not about we did not interview the customers who will just come and go. We actually targeted those the shopkeepers, the facilities management team, and so on and so forth, who are going to who worked there for more than 8 hours a day.
Okay, and that population would also include some part-time employees, right?
Yes, we do. And that's why we
Okay.
have the question for hours. And
Okay.
when we conduct the regression analysis, we do control for those variables.
Oh, okay, great.
Thank you for raising this.
So let me carry that question a little bit forward.
Uh-huh.
So I noticed that you had fantastic response rate, 340 or so responses that you received. So my question was going to be, was this a targeted population? Or because when you say that you're measuring signage, so I'm assuming that in underground spaces, you're capturing how do they find their way, or how it is easier to use the signage for wayfinding, and whether color coded or black and white or different shades are useful or not. So and then you chose subways and malls and other places where people are coming in and going out. So to Philip's point, was this a targeted population that you had chosen? And what was the success of your phenomenal response rate?
In fact, the response rate was around lower than 30%, not that high. But we have to spend a week in each site in order to get that in order to get those data. And then in the survey, we ask the respondents to indicate their satisfactions towards different aspects of the signage system. And then we put those indicators into the VR models too.
I see. Okay.
It's not
Well,
easy in Hong Kong. People
no,
are
I
always,
can imagine. Yeah.
yeah.
So we are just about out of our time, but if somebody has a pressing question, anybody? Philip, any other question?
No, that's all that I have for
Okay.
today.
For today, yes.
Mhm.
Anybody else? Any question? All right. Well, let me ask my last question, which I try to do always, is that given your study and given that you had a focus on underground environment, and given that to my earlier question about more and more people finding reality in virtual environments, uh, what would be your recommendation for underground space so that it is more pleasing, more engaging, more productive, less fatigue, etc., etc.?
Thank you very much. To answer this question, because this study only covers a small part of the underground environment. In fact, within an underground environment, there are lots of indicators. My suggestion is to bring in as much natural characteristics as possible, like greenery, like the views, and in terms of the design, we can actually enable some sorts of natural lighting and natural views from the design. We can have big atrium, even though we are utilizing the underground space, but we can still enable some sunlight to reach the bottom part of the building. This is getting more and more common, and this could be beneficial to the rental income of those lower parts of the shops as well, because traditionally those rental areas would be cheaper, right? Because there is no sunlight. But I can't remember the name, but there is a very famous shopping malls in Singapore. They have an artificial river at the bottom of the shopping mall, and that's actually basement. But when you walk through there, you didn't feel like you are in the basement, and you can see all the luxurious brand nearby. So it's not just about enhancing health of your occupants, but it can also bring along financial benefits as well.
Well, thank you very much. This has been indeed a very interesting seminar, as you
Thank you
can
for
see
your
from
time.
for the extent of questions. So we really appreciate. It's midnight. It's past midnight over there. So really thank you very much.
Thank
And
you.
with that, we conclude this seminar and then the seminar series for this semester. And I thank all the audience from all over the world, and of course from Purdue University to have participated in this. We'll be taking a break, and we'll be coming back with the seminars again at the beginning of the next semester. So until then, have a good break, and we'll see you all next year. And Dr. Chen, thank you again very much. So please
Thank
give her
you.
a big round of applause.
Thank you so much. Hope to see you all in person in future
Yes,
CIP
yes, indeed.
events.
Yes, indeed. Yeah. Thank you.
Okay. Thank you.
Bye.
Bye-bye.